Tonight's the night. We are going to fire this sucker up. I am determined. So the last thing we really need to do before we turn it on is I just want to double check everything here. This was swapped by the owner before he gave it to me when he started working on the project. And everything looks okay at first glance, but I'm just going to hit some of the solder joints with some fresh solder just to make sure they're really solid connections. Some of them look fine. A couple look like they could use a little bit of love. And then I'm also going to lift the leg of the resistors here just so I can double check that those are correct value. They look fine visually, but we'll just lift the leg just to fully confirm. And then we should be good to go. So let's go and do that real quick. All right, so I don't know if you guys will even be able to see on your end, but I added in fresh solder to all of these joints here as well as these. This one was really not, the solder was not melding with the existing solder he was using. The previous owner, you can see there's kind of this little bit of a white film that showed up on all of these solder joints, which is kind of interesting to me. I've never seen that before. I think it's probably okay. The joint seems solid, but this one was not really connecting at all. But you can see if I zoom in, hopefully you can see there what that looks like, nice and shiny. And then if you look up at, what's a good example one, like maybe up here. See, it's got kind of that white film on the exterior. This is with the fresh, nice solder added in. So I'm not sure, maybe this is a leaded, unleaded kind of thing. I mean, it's definitely solid connections. It's not going anywhere. But this one just needed a little love, and also the end of it, the wire got a little burnt, looks like, in the process. So we're going to touch up this last one here, and then I think we'll be okay. But worst case scenario, I'll have to redo all of the solder joints here. I'd rather not do that. I'm sure the owner would rather me not do that as well. But we will see. Perfect, 227, so that's totally fine. Let's put this one back in. So we're still in tolerance with this one. It is a bit higher than that, but we're still within 10%, which is all you could expect with a silver band resistor. So we're going to keep those and reinstall. Then we should be good to go here in a second. Cool. So I think we are good to go now to turn it on. Let's go ahead and put the Doghouse cover on just to be safe, since we're going to be energizing this area. And get in some power tubes, rectifier, and yeah. All right, so we got the amplifier connected to the cab just behind me. We got the current limiter in chain and a variac just off screen. All of the knobs are at their minimum setting. We got the multimeter ready to check the bias voltage and see what that looks like. We have no power tubes in and no rectifier tube. So let's go ahead and slowly bring up voltage, and we'll keep an eye on the rectifier, on the current limiter bulb. If it shines super bright, that means we got a dead short somewhere and a major issue. Now, I don't believe the previous owner, I think he said he was not able to get it to turn on when he did the cap swaps in the back. So fingers crossed there's no major issues hidden after doing all that work, but we'll find out here shortly. So let's go ahead and slowly bring up the voltage. All right, that's 120 volts. It looks like the bias supply is saying negative 45 and the schematic's calling for negative 48, so we're very close. It's slightly climbing there, negative 46. Now, one thing that we don't know, which we will find out here shortly, is if the board is extremely conductive. We did do some preliminary work to try and minimize that, but these super waxy 70s boards are notorious for being extremely conductive and very, very difficult to rid that conductivity with the board itself. Takes quite a lot of work, so the best we can do is really just minimize as much as possible. But this is looking good so far. I'm just kind of curious if I turn this, what we're getting. So we're at the minimum there. I guess in the maximum negative voltage. And so it looks like the range we have is about negative 40 volts to about negative 48, which is basically dead on the money of what the schematic calls for. So I think we should have a really solid range to bias the tubes with without having to change that resistor. So I'm very happy about that. So I'm really happy with what I'm seeing right now. So let's go ahead and grab the rectifier and power tubes and load it up and see how it's working. So the tubes this came with, it's a 5U4G. Do I have that right for the rectifier? Yeah, 5U4GB, excuse me. And then the 6L6s in this case are actually this groove tube 6L6B, which, if I remember correctly, because I had a set of these before, is not actually a 6L6. It's more, is it more a 5881? I can't remember. I'll have to look it up. But I believe they are capable or less capable than a regular 6L6. So we'll keep that in mind when we're checking the bias. And yeah, so actually let me grab, I might as well do this now. Let's go and grab the bias probe and connect it to one of the tube sockets before we turn it on. All right, so we had to lift this up quite a bit higher to fit the tall 6L6s plus the bias probe, but we're all hooked up here. I looked it up. The 6L6B from Groove Tube is actually a 5881 WXT. So we've got that in the Rob Robinette tube calculator here, tube bias calculator. It is a 23 watt tube, whereas a 6L6, I believe, is 30 watts. Yeah, a 6L6 GC is a 30 watt tube. So quite a bit of a difference there. Now again, we have the current limiter and the variac and chain here, and we will be slowly bringing up the voltage once again. Even though I already checked it, now that we got the power tubes in, they might show us something, especially the rectifier, which is getting voltage everywhere. So we'll go ahead and slowly bring it back up. We got the variac at 0 right now. Now we will have to redo, like check all this and bias it with the current limiter out of chain, because it will affect everything. So just keep that in mind. This is purely just a test to make sure there's nothing wrong. All right, so we're at 120 volts and everything looks fine. This is not on right now because we're in standby mode. So there's no power getting through to the power tubes yet. Just go ahead and run a little signal into the amplifier. I'm going to use my phone. I'm not worried about the bias right now. It's pretty, I think it's pretty cool. The tubes feel quite cool to the touch. So we'll hone that in, but for right now I just want to kind of try this. This is a new little, I bought a cord to connect my phone to a 1/4 inch. So it's a USB-C to 1/4 inch. Go into the input jack, and then I can pull up a signal generator. It's quite late, so I can't really do much, but we'll just pump a 240 hertz signal into the amplifier. Then see what that sounds like. Dirty pot or leaky voltage on those. This is a massive jump in volume. So we left this mod here. Somebody said they thought it was a tone stack lift, and that's what it seems like it might be, because the volume jump is huge with that on and off, quite noisy and a huge volume jump. So I kind of wanted to keep it in just to see what it did. Huge jump there. So, okay, great. The amplifier seems to be working okay. So now let's figure out how to bias this thing. So now that I think about it, I remember when I worked on that Bassman 50 from the 70s, very similar amplifier to this. The bias probe did not work on that either. And it might have to do with perhaps there's something different, maybe the cap they have on them or something. To be honest, I don't have the technical knowledge to be able to answer that, why. But I do recall having that issue. And so we had to do the, what do they call it, transformer shunt method or whatever. So we'll go ahead and do that real quick. So we've been letting the amp warm up, and like I said, we're going to be doing the transformer resistance method to check the bias on this thing. This is a very dangerous way to do it, so definitely don't recommend doing it. The Rob Robinette website has all the information you need to know about it. All right, I'm getting pretty confused here because I'm getting wildly different numbers now. We went from basically having them dead on matched in milliamps. This one measured 24 milliamps. This one measured 25 milliamps in the last test we did. This measured 32 and this measured 45 as we raised the bias voltage. So to me, that means it's got to be a tube thing. And as I increase the, as I mess with the voltage going to the tubes, they're just reacting wildly different from each other. So we went from 56% and 66% plate dissipation to 72% and 52% just by adjusting the bias pot. So we're going to try different tubes. I'm going to do it tomorrow because it's already 1:30 in the morning. We're going to go ahead and end here, and I'll try it tomorrow with some different 6L6s and see if that changes anything or if we got an issue elsewhere that we have to uncover. So, all right, we'll end here. Okay, we are back here with the amplifier, and I swapped in two brand new TAD red bass 6L6 GCs here, and we're going to go ahead and see if the kind of weird bias results are primarily from the 5881 WXTs or the 6L6B from GrooveTube, if those tubes are have a problem or if we have another issue elsewhere. I put the bias probe, you can see there, kind of right in the middle of the range here, which is right around 20K resistance with the pot and the resistor together. And we can check the bias voltage real quick while it's warming up. And hopefully you can see there we are getting about -45 or so, but it will warm up a bit more since we just turned it on. So we are looking at center tap is 444 point. And we dropped down a little bit. Just so variable. I'm not really sure why. 444. It's all over the place. We'll just say 444 because that seems to be kind of bounces around between mid 443s to kind of low 444s. Or is it now just going to settle it? Oh, now it's dropping even more. What is going on here? I mean, I just have to assume it's just, you know, there's some voltage on the board, which there is, if you can see that. So half a volt. Yeah, this thing's going to be a pain. We got a lot of voltage on the board. Almost a volt there. So even where we cleaned and we're pretty thorough, we're still getting 0.1 volts. Yeah, it's just kind of nature of the beast with these waxy boards here. So we're back up to 440. Oh, now we're at, we got, geez. Okay, center tap now is showing 441, maybe? All right, we're just going to go with 441 because I don't have all day to wait for this. So now let's go ahead, hand in the pocket, and get the plates. Right tube, so 441. Right tube is, of course, now showing 441. And it just jumped up. So strange. Well, there's no way this is higher than what's on that end, so this makes no sense. 440. This has got to be a voltage thing on the board or something that's messing it up. It has to be. Just so variable. I'm hoping, yeah, you guys can see that just all over the place. So I'm really not sure I'm going to edit this video together. This has been kind of a mess trying to figure this out. I've done a bunch of bias measurements or attempts bias measurements using the resistance of the transformer method, and because the bias probe is not working with this setup and I cannot get consistent results. I know for a fact that it's not going to red plate even with the adjustable bias pot turned all the way to its minimum setting there. That's not an issue. So we don't have to worry about that, but I just don't feel super comfortable because I cannot get consistent results. The numbers are bouncing around. I'm connected the multimeter to the plates or to the center tap of the transformer right here. The numbers are just bouncing around so much that I don't feel like I can get a good result. And I'm getting wildly different mismatches between the two power tubes, leaving everything else the same. So I just don't really understand that. So really my theory is it's got to be something to do with either leaky caps or it's you know, a lot of voltage in the board itself. And we already tried removing as much voltage as we could when we swapped the cathode bypass caps. I mean, you'll see there's no wax anymore anywhere around them. We got all of that removed, but that doesn't mean that there's not conductivity in the board still, which is nigh impossible to remove. I mean, you have to heat it up, use isopropyl and all that fun stuff, which is not fun at all, let me tell you. Smells terrible, not fun, super sticky, and even still it can be kind of, you know, you can still have just voltage there. And despite putting in hours and hours of work, really the only surefire way is to more or less remove all the components and treat the board separately and then repopulate it, which is extremely time consuming and thus expensive. So we're not going to be going that route, but we will be going through and just kind of trying to remove some more wax in some key places and just kind of in general, any place that's got some eyelets that are close to each other. We're also going to go ahead and spray deoxin all the pots because we noticed that might have been this pot or this one in particular was pretty scratchy, potentially voltage there. I didn't check voltage, but we'll start by cleaning all of them and then circle back to turning it on and seeing what's what. So this will probably just be a time lapse of me working, but let's get to it. I forgot to hit record, but basically what I've done is just kind of try to clean out some wax in this area. And now I'm lifting the legs out of this eyelet right here so that we can heat it up, get it really cleaned out. And then we can also test these caps for leakiness while we're doing that, because you have to have them up and out of the eyelet to be able to test those in that particular position. And then to do this, you have to take a 1 meg resistor. I don't know if it has to be a 1 meg, but this is how I was taught. And basically I just need to tack solder this and this together real quick. So now these two are connected. We got this connected to ground, and then we'll grab our multimeter. So we have no power tubes in it, but you can see we have, 308 volts or whatever on this side. And then the other side, we want to see nothing, and we see nothing. Now, if you put it on this side, you're going to get some erratic numbers. Hopefully you can see that. In the 1 meg to ground, I can't remember what it is. There's a reason for that, but I can't remember what it is. Something to do with, gosh, I don't want to misspeak, but anyways, the 1 meg to ground kind of quiets that down, and we can see that that cap is totally fine. So we'll do the same for the other one. The other side of the 1 meg is fine. Okay, cool. So now turn it off, let it drain, come back, remove these leads right here in this eyelet, let it cook for a bit, put them back in, try not to burn the insulation, turn it on, check for more leaky voltage elsewhere, rinse, repeat. So I think I'll probably not record all that, so it's easier for me to edit later, because it's going to be an absolute nightmare. This video is going to be extremely hard. So yep, that's the game plan, and I will keep on keeping on. All right, mild update here. So I've got the amplifier on right now. I've just been checking for leaky voltage everywhere. And I just wanted to show something on camera real quick. So I've got the multimeter hooked up. We're in DC volts. We're on the other end of the cap. This is where one of the ones I had to lift. And you can see it showing the bias voltage because of where it's connected to. So that's why you have to lift up that cap to be able to test it. So we're showing negative 51 volts here. Showing on this side, it should be about the same. We are negative 51. I adjusted the bias balance pot to get both of them to be the same. See that 51 and all. So before they were quite mismatched with the bias balance pot, how I had it set. So now they're basically identical both sides. So that's solid. And then if we go to right here, again, this red lead right here is going to the grid through the grid stopper. And then this white is doing the same. You can see that there. So that all looks good. So I don't really understand why we're getting such wildly different voltages. So now if I go here, see, this is still varying a bit, which I don't really understand why. This is the same issue we were having, because there's nothing really around for there to be leaky voltage to cause an issue. I guess there is a lot of leaky voltage here, so I take that back. And there's nothing here. You can see that. I mean, I have doused this area with isopropyl and heated it up. So I guess the other solutions, I could clear out these eyelets, superheat them like I did these 3 here, and see if that clears it out. And then, so that's one thing. And the other thing is that this cap right here, so I did lift all of these leads out and superheated this eyelet, and we're still getting 0.5 volts here. If I go next to it, we're getting nothing on the board itself. But this cap, if I connect directly to the cap, we're getting 0.5 volts. So I think that cap might be leaking a bit there, which is part of our problem. And then the other areas I noticed that were leaking, let me see if I can remember where they were, all the way over here. This location, I think it was right here. Getting a little bit, 0.2 roughly on this cap. See, 0.2 for that cap. Probably not leaking, it's probably just the board. Not a ton, but just kind of semi-noteworthy. And everywhere else was basically good to go. I'm trying to think if there's another place I saw. Might have been here. Yeah, so right here we're getting 0.2 as well between these two caps on this eyelet off of the plates right here. See, this side's got high voltage and this side shouldn't have any high voltage, but it's got a little bit bleeding between those two, so we will clean up that area between those two. But everywhere else was fine. And you can see everything is basically 0. If I were to go to this one here, basically 0. All the way down here, 0. So overall, pretty happy with that. I just still don't quite understand why this is varying so much. And maybe that's normal, and I just never noticed that before when I'd done this method. I've only done it, I think, one other time with the Basement 50, actually, now that I think about it. But yeah, it's just so variable. I don't really get it, to be honest. So anywho, and we have no power tubes in it right now, by the way. Okay, so I'm going to go back to it. Trying to remove the voltage. We'll take that, lift that cap leg up and see if it's the cap itself or that eyelet. And if it's the cap, we'll have to replace it. I think it's a 0.1. Yeah, it looks like a 0.1. So I'm pretty sure I have a 0.1 in stock, but okay. All right, so we made some progress in some places and not so much progress in other places. I cleaned out, removed all of the leads from these two eyelets right here for the center tap. This is a very critical spot right here. This is where we get high voltage. See there, 476 volts right now. And it's still varying a bit, moving around. Hopefully you guys can see that. Yeah, you can. Still not stable, but we did remove all the voltage basically from around it, 0.006. So there's no leaky voltage there. So that's not part of the issue anymore. It's just, for some reason, not super stable. Don't fully understand that still. And then this one we saw was leaking, was it 0.5 volts before? So we lifted it up and it's not leaking anything actually. It's totally fine. But then we go back to the board here and we can see that 0.5 there. So we are still getting 0.5 volts leaking here. This side we're not getting any. And I have cleaned this area out quite a lot. We're really getting nothing on the board, not that much. 0.01, 0.02. Nothing crazy. 0.06. So I'm not sure why it's all of a sudden jumping to 0.05 when you're actually on the eyelet itself. Don't quite understand that, to be honest. Obviously missing something, but the cap is fine. I've already cleaned out the eyelet. I've taken all the components out, superheated. I did all the steps I did elsewhere where it got rid of everything. So I'm not really sure. I'll probably take it out and do it one more time just for good measure. But yeah, that's where we're at. Back to it. All right, I'm at a total loss here. We're still getting 0.5 volts, half a volt there. I took all the components out. I superheated with the soldering iron, cleaned out all the solder. I used isopropyl. I used naphtha. I used my heat gun on there for a long time. I did multiple runs at it, and it doesn't matter what I do. I cannot get. So it's not the cap. We already checked the cap. It's purely, for some reason, right around this board, or this this eyelet. But if I go next to the board, it's fine. There's nothing there. I've cleaned it all out. So yeah, you can see there's no voltage anywhere around the board. It's purely just at this eyelet for some unknown reason, which I don't really understand. So we're getting no voltage here on that side. That's going there. This side, 135 volts. So maybe this is supposed to get 0.5 volts here or something. Maybe I'm missing a piece there, but we're gonna go ahead and move on because I can't spend, hours on one eyelet. And yeah, I've done just about all I know how to do to fix that. So moving on. All right, we're back with this amplifier. Hopefully we can figure it out today. So I've got the amp turned on, plugged in the cab behind me, and I do have the bias probe back in use. And I've lifted the lead of the little cap that goes to the grid, pin 5, on this one where the bias probe is plugged into to see if it's going to work. And I'm already getting a measurement here, which I was not before. So it seems that cap was messing things up. So we're going to hopefully try and be able to bias it with this, not doing the transformer resistance method I was trying for quite a long time to do and kept getting very erratic results. So I'm very curious to see if this shows us a consistent number or if it's still erratic. If it's still erratic, then we've got some other issue. I have no idea what it is. If it's not erratic, then we're fine. And I still don't have an explanation of why it was erratic the other way. But either way, we're going to move forward. So let me grab out the Rob Robinette bias calculator here so that I can quickly tabulate everything. And we've got the 5881s back in it. So the 23 watt tubes. Turn it off of standby. Make sure everything is turned down. It is. All right, this is working. Beautiful. Okay. Goodness gracious. This seems way more consistent. So I'm already much, much happier and feel much better about this. So let's go and check it. I wish I had done this before. I didn't even think about it, to be honest. We're looking at 60%, which is right on the money. So I feel pretty good about that. Now let's go ahead and we got to turn it off, discharge it, remove the cap on this side as well, and see what that gives us. And then hopefully we're right bang on. So that's 60%, kind of exactly what I would want. So we'll go ahead and turn it off, discharge it. And I'll show that. This amplifier actually discharges fairly quickly on its own, but we will help it out. So 427, I'm going to call it in 30 milliamps. That puts us at 12.8 watts, and it's a 23 watt tube. So that gives us at 50%. So we had 60% on one tube, 50% on the other. So they are fairly mismatched, but it's not the end of the world, and mismatched tubes can be okay, and just kind of changes the sound of it. And they do have the hum balance to kind of try and balance that out, but definitely I would recommend the owner replacing the 5881s with solid 6L6s. Apologies if you hear in the background my daughter screaming. She's refusing to nap right now. My saint of a wife is helping her out. All right, so now that we've got that done, we're going to change tube sockets. We're just going to keep this same tube in this tube socket, the one that measured low, or lower, I should say. All right, so this side we're getting 428.30, so that's exactly what it was. So it seems like the hum balance is perfectly kind of in the middle, so that they're equally sharing the load. Now, because they are so mismatched, we will probably adjust that a little bit to get kind of them to be a bit more equalized. So feel pretty good about this. Now I feel like we can go ahead and actually try the amplifier, play it, do some sound tests, which will be fantastic. So let's go ahead and move forward. That sounds great. Let's try the normal channel. The amp sounds awesome. It sounds so good in person. I hope the audio on my camera picks it up semi-decently. Yeah, sounds great. Turn it up to 6 or so and really starts to get some nice breakup with the old test guitar, my Jazzmaster here. And yeah, killer. This thing should be good to go for decades and decades. Sounds really great, nice and quiet. Everything seems to be working okay. Sorry, getting a phone call there. I will be removing these caps that are just kind of lifted up here. I don't need to show that on video, and then also the little mod they did to the bright switch here where it seems to lift the tone stack. I think it's what it's doing. It makes it very loud and quite a bit brighter. We're going to get rid of that because it sounds pretty terrible in person. But everything else is rock solid. This thing is going to be good to go for a long time. I told the owner I would recommend him getting a pair of 6L6s, 6L6 GCs specifically for this. But totally his call, and this will work fine. It seems pretty silent, so I don't really need to mess with the hum balance. Yeah. Well, I thought we were done, but I plugged in one of my little shorting RCA jacks to check the trem, and the trem was extremely weak, barely worked. Luckily, I had a replacement little road tray here, so I swapped that in, and the trem came right back and sounded great. However, there's a pretty gnarly tick with it, pretty common with these vintage Fenders, and so I did the little tick fix, if you will, with this cap right here. This is a 0.01 microfarad cap from the edge or the eyelet where this, 10 meg is connected to the spot right here, which has got quite a lot of leads in it already, but I was able to just barely fit this one in there. So let's just go ahead and show it working. And again, I don't have a knob here for this, but the owner purchased one and was just going to put it on himself. So no biggie there, but the intensity is now max, and we got the trem speed, roughly half. Let's hear what that sounds like. Try not to blow out the camera mic. And it's dead silent, no tick. So awesome. The last thing we need to check is the reverb, but I can't do that till it's back over by its cab. So assuming all of that works fine, now we can end the video here. Thank you guys so much for watching. Appreciate it. If you like this content, give it a thumbs up. If you want to see the other parts of this series, to see all the other work, always check the description of every amp video I have. I create a playlist for every individual amp so you can kind of see the journey for each individual piece. And yeah, subscribe if you like this content, thumbs up, comment if you want, and until next time, see ya.